Hello everyone, I am Vedanti Kingri. My presentation is on normalization in ADBMS. My topic is along with my teammates Methli, Rushikesh, Sakshi. So let me first introduce what is normalization. Normalization is a fundamental concept in database design that aims to organize data in a way that reduces redundancy and dependency. The process of normalization involves structuring a relational database in such a way that it adheres to certain rules or normal forms, which are designed to minimize data anomalies and ensure data integrity. Next, we have key objectives of normalization: reduce data redundancy, enhance data integrity, facilitate efficient data management, improve query performance, support scalability and maintenance.
Key objectives of normalization. First, reduce data redundancy. One of the primary goals of normalization is to eliminate duplicate data. Second, enhance data integrity. By enforcing relationship and constraint, it ensures that changes in one part of the database do not lead to inconsistencies in another. Third, facilitate efficient data management. A well normalized database is easier to manage and maintain. It allows for straightforward update, deletions, and insertion as changes are localized to specific tables. Fourth, improve query performance. Although normalization can sometimes lead to complex queries due to the need for joins, it can also enhance performance by allowing the database to optimize data retrieval through well-defined relationship. Fifth, support scalability and maintenance. Makes it easier to modify database schemas as requirements change. Allow for better handling of large datasets. Key objectives of normalization. First, functional dependency. Second, normal form. There are 6 types of normal form. First normal form, second normal form, third normal form, voicey code normal form, fourth normal form, fifth normal form. Third, denormalization. First, functional dependency, a relationship that exists when one attribute uniquely determines another attribute. For example, if you have a table of employees, the employee ID can determine the employee's name. Second, normal form. Normalization is typically carried out in stages known as normal form. Each normal form has specific requirement that must be met. The most commonly used normal forms are: first normal form 1NF, ensure that all columns contain atomic indivisible values and that each column contain values of a single type. There should be no repeating groups or arrays. Rule: all attributes columns must have atomic indivisible values and each record must be unique. Goal: eliminate a repeating group and ensure that each field contain only one value. Second normal form 2NF, achieve when a table in a 1NF and all non-key attributes are fully functionally dependent on the primary key. This means that no non-key attribute should depend on a part of a composite primary key. Rule: must be in second NF and there should be no transitive dependency, that is, non-key attributes depending on other non-key attribute. Goal: ensure that non-key attribute are only dependent on the primary key. Applies mainly to tables with composite primary key.
Third normal form 3NF. A table is in 3NF if it is in 2NF and all the attributes are functionally dependent only on the primary key. This eliminates transitive dependencies where a non-key attribute depends on another non-key attributes. It has some specific rules. It must be in 2NF and there should be no transitive dependencies, that is non-key attributes depending on other non-key attributes. Goals ensures that non-key attributes are only dependent on the primary key. Boyce-Codd normal form BCNF, a stronger version of 3NF where every determinant is a candidate key. This addresses certain types of anomalies that 3NF does not cover. Rules: a stronger version of 3NF, every determinant must be candidate key. Goal: handle certain type of anomalies not handled by 3NF, especially when there are overlapping candidate keys. Fourth normal form 4NF deal with multi-value dependencies. Ensures that no table contain two or more independent multi-valued data describing the same entity. Rules must be in BCNF and multi-value dependencies should be eliminated. Goals: prevent multi-value dependencies anomalies. Fifth normal form 5NF, also known as project joined normal form. It deals with cases where information can be constructed from smaller pieces of information. Rules must be in 4NF and every joint dependency must be implies by candidate keys. Goals: eliminate redundancy caused by joint dependencies. 3. Denormalization. In some cases, for performance reasons, a database may be normalized, which involves intentionally introducing redundancy into a database design. This can be improved read performance but may complicate data integrity and update operations. The summary of normal form. This slide is a summary of the different normal form used in database normalization. The goal of normalization is to reduce redundancy and prevent data anomalies. Each normal form builds on the previous one and add more constants to make the data structure clean and more efficient. 1NF, first normal form. In 1NF, we make sure that all the data is stored in atomic form, meaning each cell has a single value, no list or set. Also, there should be no repeating columns and each row must be unique. It is a basic step to organize data privacy. 2NF. 2NF build on 1NF by removing partial dependencies. This means that in table with the composite primary keys, all non-key attributes must depend on the whole key, not just a part of it. It helps to reduce redundancy in table that used composite key. 3NF. In 3NF, we eliminate transitive dependencies. That means non-key attributes should only depend on the primary key, not on another non-key attributes. This helps make the structure even more focused and prevent indirect redundancy. BCNF, Boyce-Codd normal form. BCNF is a stronger version of 3NF. It says that every determinant must be candidate key. So if any attributes determines another, it must be unique itself. This fixes certain edges case where 3NF still allows anomalies. 4NF, 4NF normal form. 4NF deals with multi-value dependencies. For example, if person has multiple phone numbers and multi-email address, we separate them into different tables. This ensures that unrelated multi-value data does not mix in the same table. 5NF, fifth normal form. 5NF eliminates joint dependencies. It ensures that if we break a table into smaller ones and then rejoin them, we don't accidentally create wrong or duplicate data. It is useful in very complex data structure involving multiple relationships. Domain key normal form. DNF is ideal form where all the constraints are based only on domain rule, valid data types and key rules. It hard to achieve in practice, but it is cleanest and more reliable form. So overall, normalization is a step-by-step process. We keep refine the data structure at the each level to avoid redundancy, maintain data integrity, and make the database easier to update and maintain.
Hello everyone, myself Rushikesh Sote. First point is benefits of normalization. In that case, first one is reduce data redundancy. By organizing data into related tables, normalization minimize duplication. Second one, improve data integrity. Ensure that data is consistent and accurate across the database. Third one, easier maintenance. Changes to data structures can be made more easily without affecting other parts of the database. Fourth one, efficient queries. Well-structured data can lead to more efficient query execution. Next one, challenges of normalization. Complex queries. Normalized database may require more complex joins which can impact performance. Overhead. The process of normalization can introduce overhead in terms of additional tables and relationship which may complicate the database design. Next point is normalization advantages and disadvantages. First one, advantages of normalization: elimination of redundancy, improved data integrity, easier maintenance, enhanced query performance, better data organization. Disadvantages of normalization: complexity, performance overhead, increased number of tables, difficulties in reporting, potential for over normalization. Thank you so much.